do all of these problems today. We're going to do some today and some tomorrow. Shh. Who didn't get one? Okay. So, shh. Everybody's got one? Okay. All right. We're going to do some today and some tomorrow. Tomorrow's homework is going to be a review, and we will have a quiz on Friday. So let's go over some of this. Shh. I'm probably, excuse me, I'm going to skip around a fair amount, okay, because I want to get to some of everything for today, and then I'll do some more tomorrow, okay? Shh. All right, let me be very clear about this. The less you interrupt and make side comments that are not necessary, the quicker we can get through this. So you do need to concentrate. I do, of course, want you to ask questions, but not random stuff, not side remarks, and your phone should not be out because I do not want to stop the class and make you all put your phones up here. Okay? I need like 15 minutes tops of your time, and we'll try to make it less. Okay, number one. We are going to list the, we're going to do it in a different order than this is. We're going to list the zeros. We're going to list the vertical asymptotes. We're going to list the horizontal asymptote. We're going to see if there's an oblique asymptote. Shh. We're going to say the removable discontinuity. That's the holes. When they say holes, it's the same thing as removable discontinuity. So I'm going to write that right on here. I suggest you do too. You don't want this to show up on a test, holes, and you not know what it is. And then we've got discontinuity. So this is just a review that we've done before. The first thing that I strongly suggest doing is seeing if the bottom, right here, shh, seeing if the bottom is factorable. Okay? So we've got the bottom as 3x squared plus 3x minus 18. I hate trying to factor when there's a number in front. Is 3 divisible by every other number in this thing? Okay. So we've got 1 over, we're going to pull out a 3. That leaves me with x squared. Can you stop talking, please? Plus x minus 6. Okay. Let's start. What two numbers multiply to give us 6 that would add together to give us a positive 1? 3 times 4 does not give you 6. Oh my God. That's okay. 2 and 3 would have to be my positive number. Okay? So, as someone who is dyslexic, you're not. It's okay. All right, so that's part of the dyslexia. Yeah. Okay. So, zeros. If we're looking right here, zeros. Are there any zeros on top? Any way it can be 0 on top? No. No, so none. My vertical asymptotes, there's 2, right? X equals negative 3 and positive 2. You're quiet, right? There should not be any talking. If you can't handle it, maybe you should move back to your seats or away from each other. Okay. Horizontal asymptotes. Remember, I'm looking at the degrees. Looking at the degrees. I've got my numerator's degrees and my denominator's degrees. My numerator is definitely smaller, so it should be y equals 0. Okay, there's no oblique asymptote because we can't dividing this by 1 is not going to work. So it's none. I didn't remove anything. And my discontinuity is still x equals negative 3 and 2. Anybody have questions about any of those?
Nope, that's fine.
We've done this a lot. We've had 2 quizzes on this. Yes, ma'am.
So why is 2 positive shouldn't be negative? Oh, no, minus.
See, that's a negative, so it's the opposite.
Oh.
Yep. Okay. So let's go down, because I think the harder part is going to be graphing. So let's go down to number 5. And we'll talk about using those for graphing. Okay? So let's list them again. We've got zeros. We've got vertical asymptote, horizontal asymptote, oblique asymptote. I put OB up here instead of OA. Removable discontinuity and discontinuity. Shh. Yes, that's the same thing as removable discontinuity. So you don't, if you're putting H down, you don't need RD. Okay, are we focused?
Yep.
Remember, you have a quiz on Friday, guys. I'm really trying to get some graphing skills into you before then. Good. Okay. Zeros. Nothing on top makes this 0, so there's not any. All right, vertical asymptote. I think I can factor this. So I'm going to change this, make sure it's a negative. We can pull out an x, and we're left with x minus 3. So what are my two zeros then? So it's positive 3, x equals 3, and what do I times x by? What would I put in place of x here to make this whole thing 0? 0. So it's 0. X equals 0. Horizontal asymptote. The top is still less than the bottom, so it's y equals 0. Oblique asymptote is not going to work. There's no removable discontinuity. Okay? And my discontinuity is still just 3 and 0. Okay. So the first thing I'm going to do is I'm going to put my vertical and horizontal asymptotes. I have at x equals 3, I've got this dotted line. And at 0, I've got this dotted line. Those are my verticals, and then my horizontal is at y equals 0. Okay. So now I'm like, I don't have any zeros, so I need to know where stuff goes. Now, do you guys see how this is divided into 3 sections? Into 6 sections, excuse me, not 3. If we look at the top and bottom. So that means I need to fill something into 3 parts of it. 3 parts need to be filled in. Okay? So, make sure you say it. All right. So, I'm going to see if I'm on the bottom or the top for right here. So, I am simply going to plug in -1. So, if I have -4 over -1 times -1 minus 3, okay? -1 minus 3 is a -2. Yep. -1 times -2 is a +2. -4 divided by 2 is a -2. So if I plug in a -1, I need to get out -2. That means we're right here. This is on this side right here. Okay. So I need to know which one it goes in for this middle part. So I'm going to plug in, I don't know, 2. So again, it's like -4 over 2 times 2 minus 3 gives me a -4 over 2 times -1. This ends up giving me -4 over -2, which is a +2. So if I plug in 2, I get +2, which means I've got to be up here. Okay? All right, which means my last part has got to be over here because they kind of have to be symmetrical of each other. Okay? All right, you guys choose. Do you want me to do 6, 7, or 8? 7 or 8? 8 you guys want the most? It's got a lot of factoring stuff to do. Okay. Shh. I'm not going to continue. I can just make this due and your homework due for tomorrow if you continue talking while I'm talking. Okay. So, remember again, I'm going to go zeros, vertical asymptote, shh, horizontal asymptote, oblique asymptote, removable discontinuity, discontinuity. Okay? So, first thing, I need to factor both the top and the bottom. The top, the only thing I can do is I can take out an x, and I'm left then with x squared minus 9. Oh, good, both of those are a perfect square. So now I can change it to x times x minus 3 times x plus 3. Okay? For the bottom here, I'm going to pull out a 3.
And I'm left with x squared minus 2x minus 3. And then can I factor that? What two numbers multiply to give us 3 that would add together to give us negative 2? What two numbers multiply to give us 3, negative 3, and adds together to give us negative 2? 3 and positive 1. Okay, so it's all factored. My zeros are 0, 3, and negative 3. My vertical asymptotes are x equals 3 and x equals negative 1. My horizontal asymptote, if I look at the top and the bottom, the top is bigger than the bottom, so there's none. Now here's the hard part. I've got an oblique asymptote that I've got to find. So I'm going to have x to the third minus 9x divided by 3x squared minus 6x minus 9. So what times x squared is going to give me x cubed? It's just going to be x, right? So x times 3x squared is 3x cubed minus 6x squared minus 9x. Okay? And then I'm going to subtract. Okay? So this is going to give me y equals x as my oblique asymptote. Removable discontinuity. I can cross these out, so I actually am going to go change the 0 and the vertical asymptote. They're no longer there because I have a removable discontinuity at x equals 3. So my discontinuity is 3 and negative 1. So did you see that? I crossed those out because they were both the same. You can't have a 0 and a vertical asymptote in the same spot. So I know that my vertical asymptote is at x equals negative 1. I know I have a removable discontinuity at x equals 3, so I've got to remember with 3 I have to get rid of it. And I have an oblique asymptote at y equals x. Okay? So then, and I know I have zeros at 0 and at, oh, just at 0. No, 0 and 3? No, that's my removable discontinuity, at negative 3. Which means I'm going to go like this. I'm going to go like this, but at 3 I need to have a hole. So that's what it looks like when I have a removable discontinuity. I've got that hole there. Okay, so let's do one more on the back, and then I'll let you guys work on your homework, okay? Let's do one more on the back. Let's do, you want to do 13? Sure. We can do 10.
13.
We'd rather do 13 though? Okay, because 10 is a lot like 8. It's almost exactly the same. So let's do 13 because that looks a little bit different. Okay, so we've got 13. The first thing we're going to do is factor the top and bottom, okay? So I'm going to take out a 2, and I'm left with x squared plus 5x plus 6. And then I know that factors to, what two numbers multiply to give us 6 that add together to give us 5? 3 and 2. Okay, let's factor the bottom. Shh. We've got x plus 2 and x plus 1, right? Remember, these cancel. Okay, so my zeros are negative 3. My vertical asymptote is x equals negative 1. My horizontal asymptote, the top and bottom are equal, so it's going to be y equals the numbers in front, so it's going to be y equals 2. Yep. Oblique asymptote, they're the same, so there isn't one. If the degrees are the same, there isn't one. We're going to have removable discontinuity, which is x equals -2, and discontinuity is going to be -2 and -1. Okay? So the first thing I'm going to do is plot those vertical and horizontal asymptotes. Vertical asymptote at -1. Horizontal asymptote at 2. Okay, so far so good? All right, so I know there is a 0 at -3, so that means right here at -3 it has to go through, so I know one of them goes this way. I know one of them goes on this side, and I remember that I have a removable discontinuity at -2. So I'm going to go this way, say there, removable discontinuity. Done. So this one was much easier to factor than I thought when I looked at it, guys. So that's better. Okay, we're going to have more notes like this tomorrow. We're going to continue doing notes on this page, but I am going to pass out to your homework now.